Doesn't work.
All right, guys. So we're going to continue with working on quadratics. We are going to deal with a couple different techniques today. So, I guess my comparison, my analogy is I kind of make a baseball analogy here. If I'm a Major League Baseball pitcher, or just any pitcher in general, and I throw only a fastball, I'm not going to be extremely successful, right? I might get a couple outs, but people are going to start hitting me, okay? I need a changeup. I need maybe a slider, or a variation of my fastball, maybe a cutter or something like that. I need other pitches to get out, okay? If you're a person that when we go over a technique, and then I show you another technique, you get the same type of solutions, okay, to address maybe the same problem. And you're saying, well, I already have method 1. I don't need method 2, okay? You're going to be somewhat successful, but eventually these problems are going to start hitting you. Does that kind of make sense? Okay? You need to be able to develop second method, third method, that kind of thing, in a comfortable or a level of comfort with them. Okay? If I'm a Major League pitcher, my changeup and my fastball, they're not going to be as efficient as one another. One is going to be better than the other. You're going to be better at one method than the other. You're probably going to prefer one method over the other. But you still need to learn them all because you're going to be able to address more things, and especially in a more efficient and timely manner if we do it that way. Does that kind of make sense? Okay? So please, when we start talking about things and you already know a procedure, don't tune me out. Because there will be times when maybe the procedure I'm talking about that you're tuning out takes 30 seconds to do the problem, where your method takes 6 minutes. Okay? So you want to be able to address those things and be able to adapt. So the first technique that we're talking about is what we call a square root method. Okay? The square root method, there's really 2 times that you can use this, or 2 situations. Okay? The first time is when the quadratic has no linear term. Okay? Meaning your b value equals 0 or no x to the first. Something like that. Okay? If we look at example 1, we have that situation. If we look at example 2, we have that situation. Okay? The second case or second scenario that you're allowed to use this square root method is when your linear term is not explicit. Okay? It's going to be something like that. Okay? It's not going to be something that you can quickly identify. It might take you a step of multiplication or something like that to figure out what it is. Okay? But it's going to be hidden inside a quantity squared. Okay? When that's the situation, you can use the square root method. And I'm going to show you that, I think in example 3 and maybe a couple other examples that we worked through. We'll start talking about completing the square here in a little bit. Okay? So those are your options, okay? Or those are the situations that you're going to use this. Now, are those the only time, or when those things occur, is this the only method I can use? No. If I look at x squared minus 4, maybe a lot of you see, I can use the product sum technique. There are 2 numbers that I know multiply together and give me -4 and add up to give me 0. -2, +2, right? Okay? So you can use that technique and say, well, that's the difference of perfect squares. X plus 2, x minus 2, I got my answers. And that's absolutely fine. That's great, okay? But when I look at x squared minus 4 equals 0 and I want to use the square root method, there's nothing wrong with that. But if you're going to use square roots, remember, solving root equations, you have to isolate x squared, right? You have to get that by itself before you start taking square roots, okay? So I'm going to get that thing by itself. I'll add 4 to both sides. So x squared is equal to 4. Xn is equal to 2, right? And we're done, right? What did I do wrong?
Plus minus.
Okay, it's plus or minus. Okay? That's not as obvious when you start using the root method as it is if I were to use difference per squares. Difference per squares, that positive, negative 2, they're going to show up right away. Okay? When I take square roots, we need to remind ourselves we're back into algebra, and there is no context to this question, so the plus and minuses have to stay. Okay? If we were in geometry and we were doing distances, the negative could probably disappear, right? Okay? And there will be times in this class where the negative will disappear because there'll be context to the problem. There'll be a story to it or whatever, and we have to address it that way. But in this situation, plus or minus 2 are our two solutions. Okay? Is that doable? All right. Let's go to that bottom one. Okay? 3x squared minus 7 equals 0. Okay? No linear term again, so I can use the square root method. Okay? You could maybe, no, you can't. So here's what I'm trying to think. And if I rewrite this as 3x squared plus 0x with a minus 7 equals 0, maybe I can use the AC method. 3 times AC gives me negative 21, or any factors that multiply to give me negative 21, but add give me 0, and there's none, right? Okay. Maybe I'll show you something here in a moment that you could do, but there is nothing that I can use the AC method with. So maybe this is my only option. So I add 7 to both sides. All right, so we get 3x squared equals 7. Okay, I'm going to divide both sides by 3. I get x squared equals 7/3, right? Okay, now what? X square root, so that's going to give me x equals plus or minus root 7/3, right? Okay, now I'm not sure on WebAssign, I'm not able to kind of get into the background real easily and see what solutions they're accepting. And there will be times where they accept radical 7/3. There will be times where that's not acceptable and they want you to rationalize it, okay? So I'll walk through the rationalization process with you here and kind of talk about why we do what we do, okay? Because I don't think maybe you've seen this in the past. You might be told that you're allowed to do this, but I don't know if your eyes have been open to why, okay? And again, I want to show you why. I want you to understand why, because at some stage in this class and other classes that you take after this, you're going to wonder, can I do this algebra? And if you understand enough of your other algebra rules, maybe you can piece things together to make the argument, yes, I can do this, this makes sense. Or no, that's not allowed because it violates maybe some other previously known rule, okay? So when I look at plus or minus root 7/3, I'm just going to start with, I'm going to kind of neglect the plus or minus, we'll just put that back in at the end. If I have 7/3 underneath the radical, you guys know from maybe Algebra 2 or even Algebra 1, and we're talking about in geometry as well, that I can take that fraction, I can put the numerator in its own root and the denominator in its own root, right? Does anybody know why? Or were you just told that's something you can do? Okay, but why can't I take square root of each other?
Because you're taking the square root of the entire thing anyway, so.
But why is, if I had, let's do a number like this. Why is, if I take 16 over 25, okay, and that's going to give me 4/5, okay, why can I write it as 16 over radical 25 first, and to recognize that that gives me 4/5? Why can I do that? You haven't addressed, because so the answers you're giving me are non-mathematical, right? You're trying to use common sense almost.
Okay, so when you are solving, when you're doing it the other way, right? Anything that's in the square root, right, is, if it's a perfect square, it's the square of something. It's something times something. When you multiply fractions, you're gonna end up with that thing.
Okay, so I think you're saying is because if I had like 16 under there, that's 4 times 4. So that's 4 squared underneath the square root, right?
Yeah,
and they're going to cancel.
Everything is...
Absolutely. Okay, but why do they cancel? Why does a square root and a power of 2 cancel?
Because they're opposites.
Not opposites, because that's plus or minus. They're inverses, okay? But what does that mean? A root function. A root function. Anything that I'm rooting, any number that I'm taking a root. What's the exponent?
1/2.
1/2, right? So this thing here is actually 7/3 to the 1/2 power, right? Does that make sense? You've seen that before. Okay. We'll make a side note. We'll go back to Algebra 1 when you start learning about your laws of exponents. If I have a raised to the m, b raised to the n, and I raise that to the c. Okay, you guys remember what we do with those things? Okay, so I rewrite this as, so I take, this is a power to a power, right? Okay, and there's other rules of why this makes sense, and we're not going to get into those right now. But that would be a to the mc over b to the nc, right? You guys agree with that? Okay. What's the exponent for 7 right now? What's the exponent for 3? Okay, so can I rewrite that as 7 and then multiply those two things? So 7 to the 1/2. And can I do that with the 3 to the 1? Multiply it by half, so I get 3 to the 1/2. Now, what is the 1/2? What is that exponent the same as? Square root, right? Here we're square root to 1/2. Let's go from 1/2 back to the square root. So now I put the 7 there, and I put the root 3 like that. Does that make sense? That's the algebraic logic why you're allowed to take a fraction, okay, and put the numerator on its own root, put the denominator on its own root. Okay? I know it's, like, why do I need to know that? Because those are the little things that make your understanding of algebra so much better. And when you get down the road to something that you have a question about, am I allowed to do this? Am I allowed to put the roots or the numerators and denominators on their own roots? Well, if I understand the progression of what radical 7/3 actually means, and I understand my laws of exponents, I can convince myself absolutely I'm allowed to do that. Okay? So now we still don't like that answer because there's a radical in the bottom, right? We want to rationalize that. That's radical 3 is an irrational number. Okay? So how do I rationalize it? Okay, multiply by radical 3 over radical 3. Okay? I multiply by 1, right? That's a convenient version of 1. But what does it do? It makes my denominator turn into radical 9, right? But radical 9 is a perfect square, so it becomes 3. It was irrational here. It is rational here now. It can be written as an a over b as a fraction. Radical 3 cannot be written that way. Okay, so we rationalize the denominator. And that's, generally speaking, the answer that we're interested in. Okay? I want to ask you to do that on tests and quizzes. I don't want radical 7/3. I want radical 21 over 3. Okay? And there'll be points attached to being able to do that. Okay? Because it's going to make things easier for you later on. Okay? Is that okay? All right. Now, when you're doing these on your own, are you going to walk through that progression every single time? No, you're not going to change radical 7/3 to 7 to the first, or 3 to the first, raise it 1/2, go 7 to 1/2, or 3 to 1/2, and you skip those steps. Okay? But I think in algebra, a lot of times when we skip those steps, when we do that for a year and a half, 2 years, we forget or we don't see the reason why those steps work, why they're allowed to be skipped, and then we start losing the understanding of when and why we should be doing some of the steps that we do. Okay? Let's go to example 3 here. Okay? Example 3, all right? It's not like the other ones. The other ones, the x squared was just an object x squared, right? There was no quantity. Now we have a quantity, but I want you to understand it's still just one object. Because when I know what x is, I add 1 to it. It's just a numerical value, right? It's one numerical value. Okay? So I'm going to treat that x plus 1 just like I was treating x in the last one. Okay? Because it's going to be squared now. So I had 2 times the quantity x plus 1 squared equals 4. It's the second scenario, and I told you, even though you got a linear term, if I don't multiply that out, if I were to FOIL that, I have a linear term. Okay? But it's not explicit. If I gave you that right away, I said, what's linear term? You're not going to be able to answer that question quickly, right? You got to do a little bit of work. Okay? If this is a situation, you can use the square root method. Okay? Divide both sides by 2, because we got to isolate the radical, right? Or so the power of 2, right? We have to isolate that term. So divide both sides by 2. Those are going to cancel. Okay, so now I have x plus 1 in a quantity squared is equal to 2. All right? When I have that, now I see that, now I'm allowed to use the square root method. Because I've isolated the power of 2, right? Okay, I've isolated that object squared. So now square root it. I get x plus 1 is equal to plus or minus root 2. Remember, we're always got to solve for x, right? So x is equal to negative 1 plus or minus root 2. Some of you might like writing, I don't like doing it this way, but you might write plus or minus root 2 minus 1. The reason I don't like writing it that way is because if you want to check what this numerical value is on my calculator as a decimal or something like that, my calculator is going to open a parenthesis, and if I don't close that parenthesis, it's going to spit back 1 to me, and that's not the answer. It should be about 0.4 something, okay, if I'm looking at the positive verb. There's discrepancy, there's ambiguity of whether this negative 1 should be under the radical or not if I write it behind. Does that make sense? Especially if they're sloppy with our handwriting. If you do write it behind, do me a favor and do something like that. Kind of put that little tab on your root symbol so I know where you want to stop the radicand. Okay? Every year I mark people wrong because it looks to me like they're putting something underneath that radical that should not be there. Okay? So that was pretty quick, right? Not a bad technique for that question. So here's my kind of try to prove a point to you. My argument at the beginning of class when I said if I'm going to be learning multiple techniques, don't pigeonhole yourself into one, because if I pigeonhole myself into one technique here, this is how I have to approach this question. Okay? Pigeonhole myself into one technique. I've got 2. I see it's x plus 1 squared, so I have to turn that into x squared plus 2x plus 1 equals 4. Okay, you guys agree with that? Okay. Now I am going to make a shortcut here, but if I don't recognize the shortcut, maybe I'm a person that distributes that 2 through this quadratic. Okay, I think I can make the argument with you guys that it's okay to do that, right? Divide everything by 2. And it's just an object, right? So it's 2 times something equals 4, so divide that by 2. But now I get x squared plus 2x minus 1 equals 0. And now I start thinking about my product sum technique. 2 numbers that multiply together give me negative 1, give me 2. Nothing does that, right? One of them has to be positive, one of them has to be negative. My only factors of negative 1 are 1 and negative 1. They don't add up to 2, okay? So I might think, well, if that's my only technique, it just ran into a roadblock, and I don't know what to do now. I can't solve it. If you know other techniques, maybe you say, okay, well, I know a quadratic formula will work. Remember the quadratic formula, if x is equal to the opposite of b, so go negative 2 plus or minus b squared, which is 4 minus 4ac, so a is 1, c is negative 1, all over 2a. So now I get negative 2 plus or minus this thing underneath the root. You guys know what that's called? That's the discriminant. Okay? Discriminant in this case turns into 8. I'll divide by 2. Now I can rationalize the 8, or not rationalize, reduce it, simplify. So I get negative 2 plus or minus 2 root 2. That's what radical 8 looks like. All over 2. And now because all 3 of these numbers out here have a common factor of 2, they can all cancel. And it leaves me with negative 1 plus or minus root 2. Same answer? A lot longer to get to? Okay? So if I'm a person that we come to class and class is 50 minutes long and we have a test, okay? And tests start and tests are over when the bell rings, okay? No staying after and finishing, that kind of stuff. I'm up against the clock. I'm not going to want to address example 3 this way, okay? Does that make sense, everyone? We have to make sure we learn multiple methods and become proficient, become skilled at them to some degree so that they can be used to our benefit. All right. So why do we use the square root method? The square root method is useful because it's a part of this next technique. Okay, it's a step of completing the square. You guys remember completing the square? It's not that friendly a lot of times, especially depending on what kind of coefficients you get. But if I want to complete the square, I'll give you a series of kind of maybe truncated steps here that you can write down that allow you to push through completing the square process. First thing you're going to do is divide all terms by your A coefficient. Okay. Same thing you're going to do is you're going to move your C to the other side. Okay, basically getting C away from your quadratic and linear terms. Okay. Those two steps are actually independent of one another, meaning that one does not affect the other. So you can do them in reverse order, or you can actually do them together at the same time. Okay. The next thing you're going to want to do, okay, we half your B term and square it. Add to both sides of the equation. Okay. So this creates what we call a perfect trinomial on one side. Okay, on the side that has x squared and x on it. That becomes a perfect trinomial, which is a trinomial that can be rewritten as a binomial squared. Okay, so I will write down, so this creates a perfect trinomial. It'll be of that format. We have some coefficient with x, you'll have some constant here. This should always be a 1x squared. So we're going to rearrange it, rewrite it as x plus some term, and that some term is always going to be what your b divided by 2 was when you halved it. Okay, so it's a good thing to kind of maybe remember what that was as you're doing step 3. Okay, now that plus sign that I have highlighted, it could be a minus sign. It's all predicated on what that sign is. If it's a plus, then the x plus b over 2 is a plus. If it's a minus I got highlighted there, then it's x minus b over 2. Okay? So once we have that on the left-hand side, obviously this is still going to be equal to something on the right-hand side. We then conduct the square root method to solve for x. Okay? So you see that in completing a square, one of our previous techniques has to be kind of mastered. We have to be able to use it. Now there are times that I think people try to avoid completing a square altogether because it is cumbersome sometimes. Okay, and they want to go straight to the quadratic formula because the quadratic formula is your catch-all. Okay, it's always going to work, right? But you can see it sometimes it's a lot more work to use quadratic formula than other methods. I try to learn, try to recognize maybe key situations, key scenarios where completing the square would be beneficial in regards to maybe the quadratic formula. Okay? If I look at this first question here, I think using the quadratic formula is going to be more work than what's necessary. You're going to see here that when we complete the square here, this is pretty simple because my a term is already 1. Okay. In example 2, I think using completing the square is going to be faster than quadratic formula. Because if I look at the coefficients for that example 2, they all have that factor of 3 in them. And if that's the case, then probably completing the square is going to be much more efficient. It's going to be quicker. But if I look at example 3, and we'll do all these. If I look at example 3, okay, look at my coefficients there. Do they all have a common factor of 2? No. So what's going to happen when I divide everything by a, I'm going to have fractions, right? And if I start having fractions and squaring fractions and adding fractions, subtract them, that gets messy. Quadratic formula is more applicable to that question because of how those coefficients relate to one another than what completing the square is. Okay? But what I want you to understand is that if we just start with ax squared plus bx plus c equals 0, and we go through those 5 steps, does anybody know what that generates? If I just start with ax squared plus bx plus c equals 0, that general generic quadratic formula, does anybody know if I go through those 5 steps what I develop when I do that? Probably should have seen it with Algebra 2 last year. If I'm not going to complete the square, what did we say we were going to do? What was our other option? What were we talking about here? We're talking about quadratic formula, weren't we? That's going to be another option. That's going to be, you said that's your catch-all. That's what we can use to always get a solution. The quadratic formula is completing the square. Okay? It just kind of circumvents all the work because somebody's already done it with ax squared plus bx plus c for us with those arbitrary values of a, b, and c. Okay? So we'll do a couple examples maybe tomorrow. I will show you the proof of the quadratic formula because it kind of sounds like maybe from your responses to this you've never seen it derived. So we'll talk about that tomorrow. So looking at this example 1, again, pretty straightforward. Divide everything by a. Well, a is 1, so it's pointless to do. So I'm going to then move my c term to the other side. Okay, so move that c term to the other side. Now I'm going to look at my b term. I'm going to have it. Okay, and then I'm going to square it. So negative 8 divided by 2 is negative 4. Square that, you get 16, right? Add 16 to both sides. Okay, always got to keep this equation balanced. Now what we've done, we're now at step 4, says this creates a perfect trinomial. That is a perfect trinomial. Meaning it can be rewritten as x plus or minus something, because that's a minus, this is going to be a minus, squared. But now I just got to figure out what that something is. And looking at step 4, it says it's always b over 2, right? Well, b was negative 8, over 2 would be negative 4. And at that step, guys, I always check myself. I always make sure that I have the right thing in those parentheses. Because I can do x minus 4 squared. X minus 4 times x minus 4 gives me x squared. Minus 4x plus 16, right? Is that exactly the same thing as x squared minus 8x plus 16? Yeah, these two things are the same. Don't go on with this question until you verify that what you have written here will multiply out, will FOIL out to give you that up top. Okay? On the right-hand side then, you have 3. Does this problem now look like the last example we did in the square root method? Okay, use square root both sides. And then add 4. And those are my 2 solutions. Okay. If you ever want to check yourselves with your answers, you should be able. Those are just x values. You should be able to plug them back into the original and get a true statement, right? Okay. What I like to do, I did this last class, so I'm just gonna just show you. I'm not gonna type it in. But using Desmos is a nice thing because now I can see that that was my x. I squared it minus 8 times my x plus 13. You see it gives you 0, right? You can check that pretty quickly. What's nice about using Desmos is I can check both the answers real quick. And this will be something you have to do eventually, because sometimes you get extraneous solutions with some of our procedures. So you have to check your answers. But in both cases here, so we get 0 for both of them, right? TIA 384, you can do that. It's just the functions for being able to type a lot of stuff in an efficient way is kind of messy. Is that something we can do? Hopefully you realize that is the first thing is that the sum technique's not going to work because 13 is a prime number, right? So 1 and 13 are only numbers that are going to be able to be added or subtracted together, and they'll never give you -8. So that doesn't work. The AC method obviously is not going to work. And the square root method doesn't work, so we got to get down to completing the square here. If you want to use quadratic formula, absolutely, it works. But it's messier. And the reason it's messier is because of the simplification process. And you guys know opposite of b. Opposite of b, so we go 8 plus or minus b squared. So that's 64 minus 4. A is 1, c is 13. All over 2. Okay, that's the answer. Okay, that is exactly what I need. But is it in that format right there? So I got to go through this work, right? I got to know what 64 times or minus 42 is, and then I got to simplify that, and then I got to divide 8 and 2, and then my coefficient for my radical. So I have a lot more algebraic work to do there. That might be a little more difficult than completing the square process was, at least for this problem. Okay, so it's always nice to have multiple methods, but what's even nicer is to know when to use those methods. When are they applicable? When does it make most sense for us to use those? Again, this one here, if I was to use a quadratic formula, just real quick give you a rundown of what that would look like. Quadratic formula is going to say x is equal to 12 plus or minus 144 minus 4ac all over 6. And now I've got some order of operation stuff to deal with. I've got some understanding of how I work with radicals, simplify those, that type of stuff. Where if I use completing the square, I can avoid some of that work. Okay? Now, like I said earlier, I'm going to use completing the square here because that 3, that 12, and that 6 all share that factor of 3. So I'm going to divide that. So x squared minus 4x plus 2 equals 0. So that was the first step. Divide everything by a. Second step is to move c to the other side, right? If you're a person that says, I can do steps 1 and 2 together at the same time, by all means do it. Okay? When I was in so I don't know if she still teaches this way, you can actually do this with some thought by just keeping everything on the left-hand side. Miss schools used to teach that, 20 years ago when I was in school, or however long ago it was. But I think it's a little bit more confusing because you got to kind of think backwards sometimes. So I always move it over to the other side. So now you take half of this term, you -2, you square it, you add that here, you add that here. Hopefully you realize that, or you think that all the math we've done so far is a little bit simpler, a little bit smaller numbers than anything that's up here. The left-hand side becomes x minus what? X minus 2. Right-hand side becomes 2. Square root both sides. Okay? And then add 2 to both sides. Okay? So much quicker finding, I think, those solutions there in the red than it is to simplify the quadratic formula up there. Okay? Is that all right? Now, that being said, you still have to have the skill of simplifying quadratic formula because sometimes you have to use it. Sometimes that becomes the technique that is going to benefit you the most. And I think you might see that in this next example. And the difference in this example, guys, is that 2 and 7, they don't share any common factors, right? They're relatively prime to one another, so they're not going to divide like they did in the last one, and the math here is uglier. Okay? And the reason the math is uglier is because we're going to develop fractions, and some of us don't like dealing with fractions. Okay? So I'm going to divide everything, using the completing the square, we're going to divide everything by 2. Okay, at the same time, I'm going to move my c term over. So this should look like x squared plus 7 halves x. This becomes a 2, but I move it to the right hand side, it becomes -2, right? Alright, so here's the problem. I'm going to take 7 halves, and I have to half that. Okay, I have to cut it in half. How do I, through multiplication, cut something in half? What do you multiply by? One half, right? I want to divide it by 2. When we say we're going to have it, we're going to divide by 2. But 7, a fraction divided by something else, a fraction divided by a fraction, turns into multiplication, right? So I'll take 7 halves, I'm going to multiply it by 1 half. And that gives me 7/4, right? So b over 2, my b over 2 term is 7/4. I have to square that, okay? And this is where, if you remember back to geometry, I always try to convince you guys, do not write things as decimals, because of the operations you got to do later. Learn your fractionals. Because if I took 7/4, okay, or even if I just took 7 halves, or it was 3.5, and I ask you right away, in your head, cut it in half. Are we going to get 1.75? Probably most of us will, okay? But now when I say take 1.75 and square it, take 1.75 times 1.75 in your head, are you going to be able to keep track of the 4 decimal places? Are you going to be able to carry your ones and all that kind of stuff? Okay? Probably not. But if I look at 7/4 and I ask you to square that, how do I do that? What's 7/4 going to look like? 49 over 16. Okay? So that's what 1.75 times 1.75 is. So much quicker, right? If I add to the left hand side, I got to add to the right hand side, correct? Okay? Starts to get ugly, but what's nice is that the left hand side becomes x, whatever that symbol was, so plus. Okay? My b over 2 value, right? My b over 2 value was 7/4. We'll square that. Just real quick, when I multiply that out, I'm going to get x squared plus 7/4 x plus 7/4 x, which gives me 14/4 x, which is 7 halves x, so that's good. And then 7/4 times 7/4 gives me 49/16. So I know that this here, when I FOIL that, will reproduce that. Okay? Now the right hand side, a little bit messier. I've got 2 fractions now, right? What do I need in order to add those? Common denominator, what's that common denominator going to be? 16. So if I multiply the bottom by 16, I'll multiply the top by 16, right? Is negative 32 over 16 still the -2 that I had there? Absolutely. So now I can add those, and I get 17, right? 17 over 16. 17 over 16. Now I can square root both sides. So x plus 7/4 is equal to plus or minus radical 17. What can I write that denominator now as? 4. Now what do? Subtract 7/4 from both sides. Get negative 7/4 plus or minus radical 17 over 4. And because they have a common denominator of 4, if I need to or want to, I can write it that way. Okay, as one condensed solution. A lot of extra work there with fractions and understanding exponent rules and all that kind of stuff, right? And we got time to do this, so I want to go through and show you the efficiency of recognizing when I do completing the square here and that term there becomes a fraction, I probably am going to try to avoid using completing the square. Okay? Let's see if we get the same answer a little bit quicker using the quadratic formula. So remember, we go opposite of b, plus or minus b squared, 4 minus 4a, which is 2, c, which is 4, all over 2a, which is 4. When I'm going to work with my discriminant here, it's 49 minus 16, right? I'm sorry, 49 minus 32. 4 times 4 is 16 times by 2 is 32. So 49 minus 32. Right, negative 7 plus or minus root 17 all over 4. Is that the same exact answer? Was it much more efficient? Yeah, so hopefully through some of the examples we've done today, you see the necessity of not just seeing a problem and instantly just start going through it and just solving it using method A. But before you do anything, before you start working, look at your problem. How do the coefficients relate? How have we talked about method A compared to method B compared to method C? And take that 10 seconds to decide a best approach. Because that 10 seconds that you waste in regards to deciding might end up saving you 50 seconds, 2 minutes, something like that. Okay? So be thoughtful of what you're doing. You guys read books all the time in literature class, and as you're reading that, you sit down and you discuss, okay, what do I think is going to happen next, right? You do that foreshadowing, am I correct? You watch movies, you do that. You watch sitcoms, you do that. Okay? Whether it's conscious or subconscious, you do that. Do that in math. Okay? Foreshadow. Think about what are my next steps going to provide me? Easier work, harder work? Do I want to go that route if it's harder work? Okay? I want to show you, or at least kind of help you work through an example in your homework. A lot of people have asked this question. I'm actually going to extend the homework through Monday. Okay, so we'll be due on Monday instead of tomorrow. But I have added some questions to it. Okay, so if you completed it 100%, you got about 6 more questions in there that you got to go back through and do. Okay, and those 6 questions probably be a little bit easier to be addressed after tomorrow's class. But I think you can probably do them. If you've already got all the other story problems done and correct, you can probably do the ones I put on there. But there was a question, it looked like something like this. It looked like S is equal to, I'll go n plus 1 over 6. Okay? It's like question 8 or 9 or something like that, I think. And it asks you to solve for n. Okay? Well, this is a quadratic equation. You just don't see the n squared yet. After I do a little bit of work, I want to start solving. This is one of those questions where you have to solve for an unknown variable. Okay, and we're going to see a lot of these in this question, or this class. Multiply both sides by 6. Gives me 6s and n plus 1, right? Well, if I'm going to start solving this, I need to look at that and know that that's a quadratic, n squared plus n. And when I see that, I need to know that this is just my c term. So 0 is equal to n squared plus n minus 6s. Okay? Now think about this. This is the reason we got to know all these different methods. If I look at that 6s, negative 6s is an arbitrary value. Are you going to know what 2 numbers multiply together to give you that and add up to 1 for my n? No. Can't use the product sum technique. I can't use square method technique. Okay? What's my catch-all? What will always work? Quadratic formula. Okay? So n is equal to the opposite of b. So b is 1, a is 1. So opposite of b plus or minus b squared minus 4ac is negative 6s. All over 2a. Okay? Negative 1 plus or minus. This becomes 1 plus, what, 24s? My s is looking at 5s. Okay, all over 2. You can type it in that way. If you get it wrong, WebAssign actually types it in or will show you a result that looks something like this. Because this is 2 fractions. That's a fraction and that's a fraction, right? So what they do is they separate them like that. Okay? There's a 1 out there. So what they do is they say, well, I'm going to rewrite it this way. And just trying to show you if you get it wrong, what's going to happen. They write that way. And now let's say you got 1 term, you got 2 terms, they both got a half in them. They're going to do this. Plus or minus 1 plus 24s. And to be honest with you, I think they should put the minus 1 at the end. But that there, and it's all about understanding our rules of algebra and order of operations, that kind of stuff. That says the exact same thing that does. But if you're getting it wrong and you don't recognize that, you might be thinking, well, I don't even have a clue on the right approach to doing this. because it doesn't look like the results that we get usually with the square, or sorry, the quadratic formula. Yeah? There's some story problems tomorrow's class. We'll talk about story problems. Make sure maybe in the next couple hours you check your email. If you haven't done so,